Okay, here we are on the next part. We're taking pairs of socks from a drawer. We've got 7 black, 8 pairs of white socks, and 5 pairs of brown socks. Simple probability. If we take 3 pairs of white socks in a row, that's assuming we're not putting them back. You'll often see I'll phrase it so all at once. So you've got really 3 blanks, and choosing 3 pairs of white socks, there are 8 pairs of white socks, so that's going to be 8 white socks out of a total of 20. Okay, so probability is all about things we're interested in. 8 white socks out of a total of 20. Once I've taken 1, there are only 7 left out of 19, and then 6 left out of 18. And you can try to cancel a little bit if you want. 6 and 18 will cancel and give me 3. 8 and 20 will cancel and give me 2 out of 5. And that's about all I can do. So 5 times 19 is 85, times 3 is 255, 14 over 255, I think. You can check that in your calculator, but that's the way you do it. What is the difference between continuous and discrete outcomes? I will write it down in more detail when I post online, but basically continuous outcomes, think of those as geometrically between a starting point like 0 and a finishing point like 20 minutes later. When might I call my mother-in-law between 8 and 8:20? It could be anywhere along here. That's continuous. There could be an instantaneous that's, the square root of 10 number of minutes after 0. That could be right in there. Discrete, think of that more like a digital clock where it clicks and you're writing down the time. It can only be 8:01 or 8:02 or 8:03. Or rolling a die and you get a 1, 2, 3, 4, 5, or 6. So these are fixed and finite, and these are infinite in nature. Think of continuous as geometrical. Alright, I'm going to hire 10 employees from a pool where the probability of hiring a guy is 35% and a woman is 65%. If I have exactly 8 people out of 10 will be women. Think of it this way, always as 3 blanks. The question is, what's the probability that I'm going to hire a woman? That is 0.65. I'm going to hire 8 women, so raise that to the 8th. The probability of hiring a guy is 0.35. Only 2 guys are going to be hired. And then I can mix them up in a bunch of different ways, and that's going to be 10C 8 number of ways, or 10C2. It doesn't matter. The symmetry of Pascal's triangle, they'll both be the same. Try that in your calculator. When I crunch the numbers, in case you haven't done this in a while, you just type in 10, hit math, go to PRB, there's NCR, option number 3, hit 8, hit enter, 45. And then I multiply that times 0.65 caret to the 8th, and multiply that by 0.35 caret to the 2nd, and that's 17.5%. Is 0.175 is approximately 17.5%. That's this answer right here. If I say that 8 or more of the people hired would be women, that's the probability of 8 women, and then I could do 9 women and 10 women and add those up. Alright, so this would be then 10C9 times 0.65 to the 9th and 0.35 to the 1st, and then this would be 10C10, 0.65 to the 10 and 0.35 to the 0. But both this one and this one are 1. So all I need to do is 0.65 caret to the 10, and I'm going to get 1.3%. Okay, and then to do this one, you type that in and see if you can solve it. 10C9 times 0.65 to the 9th times 0.35 to the 1st. It's going to be probably around 6%. Again, you can check online for the printout. I want to save time here. Alright, the classroom consists of 20 students. 12 boys and 8 girls, and 8 are wearing glasses, and 3 of those glasses wearing people are boys. I would strongly recommend drawing a little chart like this. If you make it about 4 by 4, that's pretty easily done. And I'm going to have the total be 20 down there. This is boys, this is girls, this is glasses, GL, and this is no glasses. Okay, I know that I've got a total of 12 boys, I've got a total of 8 girls. 8 students are wearing glasses. That's a bit boring. I didn't mean for it to be confusing. I should have chosen different numbers. 3 of them are boys, so 3 are wearing glasses that are boys. If there are 8 that are wearing glasses, that means there are 12 that are not wearing glasses. If there are 3 boys that are wearing glasses out of 12, that means that there are 9 that are not. And if there are 12 that are not wearing glasses and 9 of them are boys, then there are going to be 3 girls there and 5 right there. So they should add to the totals this way, they should add to the totals that way. Okay? Well, what's the probability of there being a boy? That's going to be 12 out of 20, and that's equal to 3 out of 5. Probability of a boy and wearing glasses. So the only boys that are wearing glasses, there are 3 of them out of 20. Probability of a girl or wearing glasses. Well, it could be any of these girls right here, or it could be the boys that are wearing glasses. So that's going to be 5 plus 6 is 11 out of 20. Okay, you don't want to count the girls that are wearing glasses twice. That's the mistake that's often made. They'll add up the glasses wearing people and then add up the boys or something, and they'll get the wrong total. This bar stands for if we know that the group of students we're choosing from are wearing glasses. Given the fact that we're choosing someone that wears glasses, what's the chance that it's a boy? Out of all the kids that are wearing glasses, there are 8. 3 of them are boys. So this is 3 out of 8. Just know what that bar means. 22. How many different ways are there for 12 runners to finish a race first, second, or third place? Order does matter. So this is 12P3, where order matters. Again, take your calculator. It's going to be 12 times 11 times 10 and see what that's equal to. How many different ways can 6 people be chosen from 19 to go to lunch early? Order doesn't matter. They either go to lunch or they don't. C is when order does not matter. And I'll let you put that into your calculator and find out what that is.